Hi, welcome to EcoSense Electric Vehicle Lab. Today we are going to showcase two of our newest addition to the Electric Vehicle Lab. The first system is BMS Learn and Build system. The other one is Battery Cycler system along with the environmental test chamber. So what we do here is we put the battery inside the environmental test chamber, attach it with the battery cycler, and we do charging and discharging runs on the battery so that we can estimate SOC, we can estimate SOH, we can study about behavior of battery at certain temperatures, at different humidity levels, and we can parameterize the characteristics of the battery properly. Using this BMS Learn and Build system, what we can do is we can bring our own battery pack, and the circuitry which is presented at the front behaves as a BMS. So BMS has basically four functions. The first function is measuring cell voltages, measuring battery pack voltage, measuring battery pack current. The other function is also measuring temperature, humidity data. The other function is balancing the cells. The third function is the protective function. So if anything goes over current, under current, over voltage, under voltage, so the battery pack is protected. So it triggers a relay and cut off the battery pack from charging or discharging, and basically protecting the battery pack at each and every level. The fourth function is estimation. So we can do SOC estimation and SOH estimation using the same system. Here we have built 5 types of SOC estimation: Coulomb counting method, hybrid Coulomb counting method, OCV method, Kalman filter method, and extended Kalman filter method. So we are going to showcase each and everything one by one. So let's start with the BMS Learn and Build platform first. So this is BMS Learn and Build platform. Here what we have is an open battery pack. So you can see these blue cells connected in series and parallel. Here we have 23S and 5P combination, which is the maximum for this system. If you want to bring your own battery, it has to be under 23S, which means 23 cells in series, and 5P, which means 5 cells in parallel. So in total we have a 72 volt and 30 Ah battery pack here. What we can see here is this is the distribution board where we can connect each of the cell to the BMS part. So this input section is basically coming out from the cell, and we are connecting this individual cell inputs to individual cells output, which is going to the BMS section. Now explaining this section, so basically a BMS is of this size. So this is a market standard BMS from Dali, which has come with this battery pack. So we have actually created this size of BMS into this whole circuitry so that we can make students learn how a BMS system works. So what we have done here is from this distribution board, these two PCBs are connected in parallel. So basically each of the cell along with the ground we are getting here. And this section, so now this is being distributed into two sections, this section and this section. So this is the section where we are measuring each cell voltage. So this has 23 cells, we are measuring 23 cell voltages. For measuring 23 cells voltages, what we have done is we have made a voltage divider circuitry. So each of the cell connects with a voltage divider circuitry. So for cell 1 the input voltage is 3.2 volt, for cell 2 it will become 6.4, and for cell 23rd it will become 7.2 volt. With each of the cell there is a voltage divider circuitry which gives a voltage output of 2 volt each. So for cell 1 we are getting 2 volt, for cell 2 we are getting 2 volt, and for cell 23rd also we are getting 2 volt. So these 2 volts are going to be here. What we have are 2 multiplexers. So this is a 16 channel multiplexer. So the 16 cell voltages are going into one multiplexer, and the other cell voltages are going into the other multiplexer. These multiplexers are getting signal through this STM board. So the STM is actually measuring the voltages of each of these channels. Now this STM is connected to the labbing platform where we have developed our software, and we can see each of the cell voltages. Now coming to this circuitry, so this circuitry is specifically built for balancing of the cells. So again we are getting all the 23 cell channels here, and these are the balancing resistors. This is 36 ohm half watt resistors, and when the balancing conditions are met, so the balancing conditions are met when these cells are in charging state, and when that happens, what we have defined a threshold that if the cell voltage goes above 3.4 volt, it will start balancing itself. So when any of the cell goes above 2.4 volt. These relays get triggered. So each cell have one single relay, and these relays will get triggered, and then this balancing circuit will switch on, and it will balance the cell from 3.45 volt till 3.4 volt, and that's how we can balance all the 23 cells. The circuitry which you can see in between here is basically a voltage shifter, because the STM boards can generate only 3.3 volt at the pin, but to switch on these relays we need 5 volt. So this is a 3.3 to 5 volt voltage shifter, and using this voltage shifter we are getting these relays switched on. Apart from this, for measuring this whole battery pack voltage and battery pack current, we have a sensor board here which measures battery pack voltage and battery pack current, and there are two more relays here. So these are the protection relays. So if this circuitry measures any over voltage or over temperature or over humidity, then the relay trips and it cuts the circuitry. Similarly, if there is too much cell voltage difference, if there develops too much cell voltage difference, I mean it goes beyond 1 volt, again this protection circuitry or these protection relays cuts off the entire circuitry. So this is how this whole thing works. The beauty of this system is you can bring your own battery pack without any BMS and test it with this system. You can check how it performs in different conditions. You can check if there is any protection circuitry required for the battery. Also, you can estimate the SOC and SOH of that battery pack using this system. So when you bring your own battery pack, you do not need to connect these inputs to outputs, because these inputs are specific to this battery pack. You just need to connect each channel at the output and remove these banana connectors. Now, let's see how the BMS system works. Since we are using the same battery cycle for the BMS training and research system, what we have to do is we will unplug this battery which is sitting inside the chamber and connect this battery to the battery cycle. Okay, so we are connecting this BMS battery to the battery cycler now. Okay, now let's see how this BMS learn and build system works. This is the software for BMS training and research system. This is the dashboard. This is the configuration. So all the voltages which we are measuring using the voltage divider circuitry, we can see all the voltages over here. We have not started the system. When we'll start, we can see all the voltages appearing here. The battery specification will appear here. There is another tab. So just for comparing whether we are measuring the voltages are correct or not, we can see the voltages measured by the DALI BMS which is connected to the battery pack. This is one section where we can measure internal resistance using DCIR method. This is the section where we can see all the cells balancing. We have kept balancing start voltage at 3.35. We have kept balancing stop voltage at 3.3, and this is our threshold. If any of the protection triggers, so we have built these many protections here. If any of the protection triggers, it will cut off the battery pack. And the last section is the graph section, where we can see battery voltage, battery current, power, temperature, state of charge, and actual capacity. Now, so let's first set up the data logger. Giving part to a CSV file, keeping this to in time interval to 1, and we want to log in seconds. Now let's start the system. So it will take some time to settle down. So we have to wait until the arc voltage appears to 72 volt. Yes. Here we can see the state of charge estimation. This is the state of charge coming from DALI BMS, which is the standard BMS coming with battery. We can change this to see Coulomb counting method. We can change this to see Kalman filter method. We can change this to see extended Kalman filter method. We can change this to see hybrid method and OCV method. So we provide this open software platform. Even you can build your own methods and verify it using this same software. So here we can see all the cell voltages which are being measured by the voltage divider circuit, and all the temperature data coming here. This is the battery specification. and this data is given by the DALI BMS, which is already attached to the system. Now let's measure the internal resistance first. So in order to measure the internal resistance, we are using DCIR method. So what DCIR method does is, at the steady states, it measures the cell voltage or the battery voltage. When we load the system or we discharge the battery pack with a high current, it measures the difference in the drop voltage and divide it by the current. So we get the internal resistance. So what we will do is we will start discharging this battery with a high current using our charge discharge system. We'll choose constant current mode and we'll discharge it by 0.5 C, which is around 12 ampere. So let the battery current reach 12 ampere. Switching back to BMS software. Now we'll switch on this button and we can see the internal resistance measurement here of each of these. So right now it is around 6.8 milliohm for cell number 1 and 6.9 milliohm for cell number 23. So this is a fresh battery pack, so it is almost zero, how it should be. Now let's keep the discharging current 0. Now we'll start to charge the battery and let's see how the balancing works. So I'll charge the battery again with, let's say, 7 ampere. Switching back to BMS software. It has reached 7 ampere. Now we can see the balancing status. So these are the cells which are in balancing stage. And we can verify this by going back to the BMS system. And we can see our relays going on and off. And this battery pack is getting balanced through these passive balancing resistors. These balancing voltage, balancing start voltage, balancing stop voltage and threshold, we can make it 3.4 or 3.5 as per your liking and as per your experiment. And this is where we are getting all the graphs. So this is how the system works. Let me switch it off. Let's see if it has logged the data. So it has actually logged the data, and there are almost 137 data sets which this software is logging, from date, time, pack voltage, pack current, pack power, SOC, SOH, cycle count, temperatures, cell voltages from 1 to 23, cell voltages of DALI data from 1 to 23, balancing resistors which are 0 and 1 at certain points, if there is any fault. So it is logging all the 167 parameters which are there in the software itself. So thank you everyone, this is how it works.